You know, usually when we talk about a modern convenience or some piece of government infrastructure, there is this built-in expectation of visibility. Like you want to cross a river, you look at a massive steel suspension bridge, and you can see exactly where the money went.
Right, yeah, the physical proof is right there.
Exactly. You look at the suspension cables, the hundreds of tons of poured concrete, the structural towers, the engineering is just right there in front of your face. It's solid. And I think we humans really like things to be visible. It gives us a sense of comfort.
Oh, definitely. It undeniably proves that a system is actually working.
Right. But then you step into the world of environmental safety or like natural resources, and suddenly that massive steel bridge is completely invisible. We are looking at an infrastructure landscape that is entirely hidden from your daily view, yet, and this is the wild part, you walk across it every single day.
It is, well, it's the absolute definition of an invisible safety net. And understanding the sheer scale of that hidden architecture is really what makes today's deep dive into the source material so incredibly vital.
Yeah, we're getting into some fascinating stuff today.
We really are. We're exploring a research dossier titled The Forecast and the Fish. And it's a really comprehensive look at the rich two-century history of America's federal earth science research institutions. Specifically, we're looking at the National Oceanic and Atmospheric Administration, better known as NOAA, obviously, the EPA's science office, and the National Center for Atmospheric Research.
And the central question we are exploring today is surprisingly profound when you really sit with it. Why does a government decide to measure its own air, ocean, and land? Because this is not just some dry history lesson about bureaucracy or alphabet soup agencies.
No, not at all.
This is a story about the hidden machinery of the modern world. We're going to look at how continuous scientific measurement serves as a vital and honestly often completely invisible tool for effective governance. It is the literal thing keeping you safe on a daily basis. And, crucially, we are going to examine what happens to everyday people when that data collection just suddenly stops.
And what's fascinating here is the sheer scale of the time horizon involved. I
Yeah.
mean, we are talking about measurements and foundational data collection that started way back in 1807.
Wow, 1807.
Yeah, that is over 200 years ago. And those initial efforts established a framework that is still actively protecting people today. It's like this massive, multi-generational relay race of data where the baton has been passed through wars, depressions, and massive technological revolutions.
So to really wrap our heads around this, to understand the history and why it matters to you, the listener, right now, I think we have to start by picturing a highly specific modern scene. We need to ground these lofty historical ideas in harsh physical reality.
I agree. It helps to see it in action.
So I want you to picture a small commercial fishing boat in an Alaska harbor. It's the night before a salmon opener. The water is pitch black, the air is freezing, smelling heavily of, diesel and salt. And inside the cramped cabin, bathed in the pale glow of a smartphone, a skipper, who actually happens to be the brother-in-law of the compiler of our dossier, and his son are preparing for the season. Right. And their entire livelihood, their actual physical safety out on that water, rests completely on betting on two free numbers.
Yeah, and those two free numbers are the absolute foundation of their entire operation.
Oh, wow.
Without them, they literally cannot leave the dock safely. So let's look at the first one, which is the weather forecast.
All right.
Now, for someone sitting in a landlocked suburb, a weather forecast is just a generic, cloudy with a chance of rain. Maybe you remember to bring an umbrella. But for this skipper, they are looking at hyper-specific wind speeds, wave heights in feet, and visibility metrics down to the nautical mile for their exact fishing grounds. And this number comes from the National Weather Service, the NWS.
And if you are a captain of a small boat in Alaskan waters, ignoring that first number is practically a death wish. I mean, the ocean up there is completely unforgiving. It doesn't care about your deadlines or your boat payments. The weather forecast is the literal line between a profitable haul and a catastrophic shipwreck.
Exactly. And then you have the second number. This is the fish forecast. It dictates the harvest limit, when the season officially opens, and exactly how long it will last before they have to physically pull their nets out of the water.
And that number doesn't just magically materialize out of nowhere, right?
No, not at all. It is derived from an unbelievable amount of biological data compiled by NOAA's Alaska Fisheries Science Center, the AFSC, and then utilized by the North Pacific Fishery Management Council to set the actual legally binding limit.
Okay, let's unpack this. So we have two numbers. If the captain ignores that first number, the weather, he courts immediate physical disaster. He risks drowning. But if he ignores the second number, the fish forecast, he risks something just as permanent, really. gambling away his entire livelihood.
Yeah, he risks overfishing and destroying the very fish stock his family and, frankly, his whole community have relied on for generations.
By trusting those two numbers on his smartphone, he is putting his total unquestioning faith in an invisible infrastructure built by thousands of scientists you will never, ever meet.
The contrast here is so vital to understand. Because to the fisherman, those numbers arrive silently, instantly, and for free on a screen. But the immense cost and the raw physical effort required to produce them is staggering. I mean, we are talking about a vast network of deep ocean buoys anchored thousands of feet down, transmitting surface conditions via satellite.
Wow.
We are talking about radio sound weather balloons. Have you ever actually looked into how a radio sound works?
I mean, I know it's a balloon, but honestly, no. I assume it just floats up and what? Takes a temperature?
Oh, it is so much more intense than that.
Yeah.
Every single day, twice a day, at nearly 100 locations across the U.S., meteorologists manually launch these massive helium or hydrogen balloons. Attached to them is a small, extendable instrument package.
Like a little weather station.
Exactly. And as this balloon ascends up to 100,000 feet, literally to the edge of the stratosphere, it is continuously transmitting atmospheric pressure, temperature, and relative humidity back to ground stations. The GPS tracking of the balloon's drift tells us the wind speed and direction at different altitudes.
So it's building a 3D model of the sky as it goes up.
Yes, and the balloon expands as the atmospheric pressure drops until it finally bursts in the freezing upper atmosphere, and a tiny parachute brings the instrument safely down. That vertical profile of the atmosphere is the absolute bedrock of modern weather forecasting models.
Wait, that is incredible. And that happens twice a day, every day, just to give us that first number on the smartphone.
Twice a day, 365 days a year, and that's just the weather. For the fish forecast, we are talking about massive, highly specialized research vessels conducting juvenile salmon surveys. They run complex acoustic studies months or even years before the commercial season begins.
Okay, wait, I'm stuck on this part. Acoustic studies. How do you count fish in an ocean you can't even see through? You can't just, look over the edge of the boat and tally them up on a clipboard.
No, you definitely can't. You use sound. These research vessels are equipped with highly advanced sonar systems. They send acoustic pulses down into the water column. When that sound wave hits something with a different density than the water, specifically the air-filled swim bladder of a fish, it bounces back.
Oh, wow, so it pings off the air inside the fish.
Exactly. And the scientists aren't just looking for generic blips. Different species of fish have different sizes and shapes of swim bladders, which create distinct acoustic signatures. So they're essentially mapping the biological makeup of the ocean using sound echoes. Combining that with actual physical trawling to verify the species mix, they build a complex mathematical model of the entire fish population.
It is wild that all of that hardware, the balloons, the buoys, the acoustic mapping ships, all of it gets distilled down to a single number on a screen. It perfectly encapsulates the promise of federal science, you know? You have ordinary, hardworking people utilizing absolutely world-class, multi-billion-dollar science, and they never explicitly paid for it out of pocket at the point of use.
And it extends far beyond just commercial fishing, too. If you were to somehow sever this data pipeline tomorrow, modern industries would just instantly grind to a halt. Aviation depends entirely on that upper atmospheric wind data, from the radio zones to route commercial planes safely.
Right, to avoid turbulence and save fuel.
Exactly. The entire logistics and shipping industry depends on marine forecasts and constantly updated nautical charts to move the global supply chain into ports. Agriculture depends on precipitation forecasts and soil moisture data to know when to plant, when to fertilize, when to harvest.
So the entire modern physical economy is quietly riding on the back of this invisible data.
Exactly. It's the engine of the economy.
I have to pause here, though, because there is a psychological paradox that the dossier brings up, and I think it's fascinating. Think about relying on these numbers, like walking a tightrope high above a canyon. But you didn't tie the safety net yourself. You didn't inspect the ropes. You didn't check the anchors. You're just trusting that someone else, some anonymous bureaucrat thousands of miles away, did their job perfectly.
The huge leap of faith.
It really is. How does a fiercely independent Alaska fisherman, someone whose entire identity is built on self-reliance, autonomy, and, braving the elements, reconcile that rugged independence with a complete, total reliance on federal scientists?
Well, it seems contradictory on its face, sure. But the answer is actually foundational to how we understand risk. That autonomy you were talking about is actually enabled by the data.
How so?
Without the data, the fisherman isn't independent. He is just gambling blindly. He is at the absolute mercy of a chaotic, violent universe. The continuous, reliable scientific measurement removes the blindfold. It transforms a deadly game of environmental roulette into a calculated, manageable business risk. The data doesn't take away his freedom, it gives him the map that allows him to exercise his freedom safely.
Ah, I see. True independence requires a reliable map of reality. If you don't know where the rocks are or when the storm is coming, you aren't free, you're just lucky.
That is a perfect way to phrase it. You're just lucky. But this incredible level of scientific reliance, this invisible net we've built, it didn't just happen overnight. Nobody woke up one day in the 21st century and magically deployed thousands of buoys and satellites and acoustic sensors.
Right, there had to be a starting point.
Exactly. It prompts a massive historical question. Where did this audacious idea that a government should systematically, continuously measure its own world actually come from? To understand the DNA of this system, we have to rewind the clock way back. We have to go to the year 1807.
Okay, let's set the stage for 1807. The United States has just finalized the Louisiana Purchase in 1803, effectively doubling its territory. The nation is expanding rapidly. But here is the terrifying reality for the coastal economy. This was a booming maritime nation that was navigating largely uncharted waters, at least by any reliable scientific standard. If you were a ship captain bringing goods into New York or Boston, you were relying on a method called dead reckoning.
Yeah, dead reckoning. It is a navigational concept that is exactly as dangerous as it sounds. Essentially, it means calculating your current position by using a previously determined position like, say, the last time you saw a known lighthouse,
Yeah.
and advancing that position based on your estimated speed, your elapsed time, and your course.
Which just sounds like a very clinical way of saying guessing based on how fast you think you've been going since you last saw a landmark. I mean, how did they even measure speed in 1807?
Well, they often used a literal chip log.
A what?
A chip log. They would throw a piece of wood attached to a knotted rope over the back of the ship, and they'd use a sand glass to time how many knots slipped through their hands in a certain amount of time. That's actually where the term knots for nautical speed comes from.
Wait, really?
That's incredible. Yeah. So they would take that rough speed, check a magnetic compass, which, by the way, could be completely thrown off by the iron on their own ship, and try to calculate where they were on a map.
That is terrifying. Because if your speed calculation is off by just a fraction of a knot and you're sailing for 3 days, your estimated position on the map is going to be miles and miles away from your actual physical position.
And miles away means you are crashing into a hidden reef instead of sailing into a deep water channel. They supplemented these dead reckoning guesses with deeply flawed British colonial charts, many of which were horribly outdated. Or they just relied on the accumulated memories of local harbor pilots who had somehow managed to survive the routes before. The margin of error wasn't just a minor inconvenience. The margin of error was measured in shattered timber, lost cargo, and thousands of lost human lives.
So enter President Thomas Jefferson. On February 10th, 1807, Jefferson signs an act to provide for surveying the coasts of the United States. He signs an appropriation for $50,000, and with the stroke of a pen, he births the Survey of the Coast, which is America's very first federal scientific agency.
And this is where the story introduces one of the most uncompromising, fascinating figures in American scientific history, Ferdinand Rudolf Hassler. He was a Swiss-born surveyor and metrologist, which is someone who studies the science of measurement itself. He was appointed as the first superintendent of the survey in 1816.
And Hassler was not a guy who was interested in the phrase, good enough. The dossier paints him as a man completely relentlessly obsessed with extreme rigor.
Oh, absolutely obsessed. To truly appreciate Hassler's mindset, you have to understand the mechanical reality of surveying in the early 1800s. Today, we use satellite geodesy. We can bounce lasers off satellites and measure the time of flight to calculate distances down to the millimeter. We can literally track the shifting of tectonic plates from space.
Right, it's all automated and flawless.
Exactly. But Hassler was building a map from scratch. That meant dragging heavy physical chains, specifically Gunter's chains, and massive, delicate optical instruments called theodolites through the muddy swamps and rocky shorelines of New York Harbor to establish a physical baseline.
Wait, I need to visualize this. What do you mean by establishing a baseline with a chain?
So a baseline is the foundation of triangulation. If you measure one line on the ground with absolute perfect accuracy and you know the angles from the ends of that line to a third point in the distance like a church steeple or a hilltop, you can use trigonometry to calculate the exact distances to that third point without having to actually walk there.
Oh, okay. So it's a geometry problem.
Yes, but the math only works if that first line, the baseline, is flawless.
So he is literally laying a metal chain end to end across miles of land.
Yes, but here is the nightmare scenario for a metrologist like Hassler. Metal expands when it gets hot and contracts when it gets cold.
Oh, of course.
Right, so if you were laying a chain in the blazing sun of a New York summer, the chain is physically longer than it is on a freezing winter morning. If you don't mathematically account for the temperature of the metal at the exact moment of measurement, your baseline is flawed.
Wow. So if they didn't measure the temperature, the chain is literally a different size.
Exactly. And if your baseline is flawed by an inch, by the time you triangulate that out 20 miles into the ocean, your map puts a dangerous rock in the middle of a safe channel.
So Hassler is out there calibrating for temperature, checking the optics, doing the complex math by hand. And because he is doing it with such painstaking precision, he is moving incredibly slowly, infuriatingly slowly, especially from the perspective of politicians sitting in Washington.
Oh, Washington was just looking at the ledger. They saw the $50,000 appropriation shrinking. They looked at the calendar, and they demanded faster results. They wanted cheaper, quicker charts so the merchant ships could get moving and start generating tariff revenue.
But Hassler wouldn't budge.
Hassler absolutely refused to compromise his scientific standards. He basically told them that a fast map is a fake map. So in 1818, Congress had enough. They fired him, they removed him, and handed the surveying job over to the Army.
I can completely picture this bureaucratic fight. The politicians want a deliverable, the scientist wants the truth. But here is the incredible part of the story. The Army's faster charts were terrible. They were fundamentally inadequate for safe navigation. Ships were still in danger. So by 1832, Congress essentially has to come crawling back.
Yeah, they had to eat crow.
They did. They reinstate Hassler, giving him his job back because they realized the hard way that a fast, cheap, inaccurate chart is infinitely worse than having no chart at all. Because a bad chart gives you false confidence.
This touches on the deep, embedded logic of Jefferson's initial bet. A public chart saves private ships. It boosts the economy. But that measurement must be brutally honest. If a government publishes an official chart and a sea captain trusts the authority of that government chart and the rocks are not where the chart says they are, the government has essentially caused a shipwreck.
Yeah, the blood is on their hands.
Exactly. Hassler famously had a motto: "It is the duty of every man to be honest and to do good." For him, scientific accuracy wasn't just a best practice. It was a profound moral imperative.
I love that quote. Thinking about Hassler, it's like hiring a perfectionist contractor to renovate the foundation of your house. It is infuriatingly slow, the timeline keeps getting pushed back, the budget is ballooning, and you are just pulling your hair out.
Right, you just want it done.
But at the end of the day, when the hurricane hits, they are the only contractor who ensured the foundation was actually level and the roof wouldn't collapse on your head while you sleep. You hate them while they work, but you owe them your life when it's done.
What's fascinating here is that Thomas Jefferson almost certainly wasn't trying to build a 200-year scientific legacy when he signed that initial bill. He was a highly practical man. He just wanted safe maritime trade to boost revenues for a young country. Yet that initial $50,000 appropriation became the foundational institutional DNA for all American federal science. It established the absolute precedent that the government has a duty to measure the physical world accurately and share that truth freely with the public.
Okay, so measuring the coastline is one thing. As physically exhausting and mathematically complex as it is, the coast is fundamentally static. Rocks do not move. A baseline measured in New York Harbor stays in New York Harbor. But what happens when the thing you desperately need to measure is entirely invisible, completely chaotic, and constantly shifting above your head at 50 miles an hour?
That is a whole different ballgame.
Right. That brings us to our next major leap, jumping to 1870, and the seemingly impossible problem of the atmosphere.
The transition from mapping the coast to mapping the atmosphere is a massive leap in scientific complexity. By 1870, scientists fully realized that measuring the weather required something historically unprecedented: simultaneous, continuous observation everywhere at once.
Because weather is connected.
Exactly. Because weather isn't a static object. It is a moving, dynamic fluid system. A low-pressure storm system sitting over the Midwest on Tuesday is going to hammer the East Coast on Thursday. If you cannot communicate the existence of that storm faster than the storm itself is moving, you cannot forecast it. You are just reporting the weather as it hits you in the face.
And the technological breakthrough that changed the entire paradigm was the telegraph. Suddenly, for the very first time in human history, information could travel faster than the wind.
That is the exact pivot point. The telegraph made a national weather network mathematically and logistically feasible. So on February 9, 1870, President Ulysses S. Grant established the first national weather service. And interestingly enough, considering Hassler's history of fighting with the Army, it wasn't a civilian science agency at first. It was placed firmly under the U.S. Army Signal Service, run by a man named Albert J. Meyer.
Which, if you think about it, makes total logistical sense. If you need a vast network of people to take highly specific atmospheric readings at the exact same time every single day across a massive, mostly rural continent, you use the military. They already have the chain of command, the discipline, and crucially, they control the telegraph infrastructure.
Right. Initially, it was a very small footprint, just 24 stations spread out across the country. The soldiers stationed there followed strict, uncompromising protocols. They had to read the thermometer. They had to read the barometer to measure atmospheric pressure. They had to check the wind direction and speed. And then they had to encode that data and send the telegram to Washington at specific intervals.
It sounds so tedious.
It was. It was not viewed as glamorous intellectual science. It was viewed as raw, grueling infrastructure work, the scientific equivalent of laying down railroad tracks.
But this introduces one of the most vital concepts in the entire dossier, and honestly, in all of modern science, the concept of the long count and baseline data. I need you to explain why a bored soldier tapping out a Morse code telegram about a cloudy day in 1870 is doing something so incredibly important for us today.
Okay, so the long count is the fundamental idea that every measurement taken in the past is actually an observation about today. When that soldier dutifully wrote down the barometric pressure in a ledger in 1870, he thought he was just helping ships avoid a squall that week. But he was actually establishing a baseline of reality.
So establishing what normal means.
Exactly. Think about it this way. You cannot know if a severe drought in 2026 is mathematically exceptional or just a normal cyclical variation unless you know exactly what normal looked like a century ago. You cannot test a modern supercomputer climate model unless you have a massive, unbroken historical data set to test it against. You run the model backward. If you can accurately predict the weather of 1920 based on the data of 1910, you know the math is solid for predicting 2050.
I see, because you cannot invent data retroactively. If you didn't take the temperature reading on a Tuesday in 1870, that specific data point is gone forever. You can't guess it. It's a blank spot in the record of the Earth.
Exactly. And the agency quickly recognized the growing, vital importance of this daily data for agriculture, not just military or maritime use. So in 1890, the network was transitioned to the civilian U.S. Weather Bureau, and it was deliberately housed in the Department of Agriculture.
I have to challenge that placement a bit. Why agriculture? Why not commerce or transportation?
Because in 1890, the weather mattered most to the farmers trying to feed a rapidly growing nation. A sudden, unpredicted frost could wipe out an entire season's crop, bankrupting thousands of farmers and causing food shortages in the cities.
Oh, that makes sense.
Yeah, by having a national weather service that could warn farmers of a coming freeze, often by having trains actually display specific signal flags on their cabooses as they rolled through rural areas. Farmers knew to harvest early or cover sensitive crops. The data was quite literally feeding the country.
Here's where it gets really interesting to me. I look at this 1870 telegraph network as essentially a 19th century steampunk version of the internet.
Oh, that's a great way to think of it.
Right. It was this primitive, sprawling web of sensory data points, all pinging a central server in Washington, D.C., trying to catch a ghost. They were trying to capture this invisible, moving fluid dynamics problem, the entire atmosphere of the North American continent, using nothing but copper wires, Morse code, and glass thermometers.
It is a brilliant analogy. They were building an analog internet of the physical world. And the stark reality is you cannot go back in time to install a thermometer. The continuous, unbroken funding of this mundane, deeply repetitive task, day after day, year after year, through the Civil War, World War I, the Great Depression, is the only reason modern forecasting is mathematically possible today.
It's just staggering to think about.
It really is. Those soldiers thought they were protecting ships for tomorrow. They were actually building an irreplaceable time capsule of the Earth's atmosphere for the 21st century.
Which is completely mind-blowing. It's a generational gift. But right around that exact same time, while the military was figuring out how to measure the moving sky, another entirely invisible crisis was brewing under the water. And this leads us to the third major leap in federal science. Let's move to 1871 and the problem of the living ocean.
Yes. In 1870, just as the weather network is getting off the ground, Commercial fishermen in prominent places like Gloucester, Massachusetts, and Long Island Sound started reporting something terrifying to the local economy.
What was it?
The fish stocks were failing. They were sailing out, throwing their massive nets, and pulling up empty water. But no one knew why, because no one had ever systematically counted the scent in the ocean. It was assumed to be an infinite, inexhaustible resource.
So in 1871, recognizing a looming economic catastrophe, Congress creates the U.S. Commission of Fish and Fisheries. And President Grant appoints Spencer Fullerton Baird, who is the Assistant Secretary of the highly prestigious Smithsonian Institution, as the first commissioner.
Baird was a true visionary. He immediately established the first federal fisheries research laboratory in Woods Hole, Massachusetts. And he didn't just pick Woods Hole because it was a picturesque coastal town. He chose it for a highly specific scientific reason.
Which was?
Woods Hole sits at a unique geographical intersection where colder northern oceanic currents and warmer southern currents mix. It made it a perfect, naturally occurring marine laboratory with immense biodiversity.
And Baird introduces a concept here that completely revolutionizes environmental science and government policy. He argued that a public resource like the fish swimming in the open sea, which belong to no single person but to the nation, requires a public count. You simply cannot manage what you do not measure.
That is the crux of it. The fishermen were coming in with anecdotal, highly localized reports. There are fewer fish in my specific bay this year. Now, that is valid experiential information, but it is not science. It suffers from what we now call a shifting baseline syndrome.
Right, where your baseline for normal is just whatever you grew up with.
Exactly. A fisherman only remembers what the catch was like when his father fished, not what it was like 200 years ago. Only a systematic, rigorous, continent-scale scientific survey could accurately diagnose the health of the entire biological stock. Was the population actually declining, or were the fish just migrating to deeper, colder waters out of reach of the nets? You need science to answer that.
It's important to clarify, though, how this differed from modern environmentalism. Back then, conservation mostly meant propagation. The idea was to build massive hatcheries to artificially breed fish and dump them back into the water to make up for the shortfall.
Right, it was very different from today.
Yeah, it wasn't the incredibly complex ecosystem-based fisheries management we have today, where we monitor predator-prey relationships and oceanic temperatures, but it was the direct ancestor. It is the unbroken lineage to today's NOAA fisheries. And Baird was so deeply dedicated to this mission that he held the fish commissioner post simultaneously with his intense duties at the Smithsonian for the last 9 years of his life.
He essentially worked two massive full-time jobs, mostly without extra pay, until he died, because he believed in the mission of the count so much.
But I'm hung up on the cultural clash here. How on earth did Baird, this highly educated academic scientist from the elite halls of the Smithsonian in Washington, D.C., convince gruff 19th century Gloucester fishermen to trust him? These were guys who relied entirely on generational intuition, folk wisdom, and physical toughness. They must have looked at him like he was an alien.
If we connect this to the bigger picture, Baird did exactly what Hassler and Jefferson did with the coastlines, but he applied it to living, moving creatures. He didn't just walk onto the docks and dictate arbitrary laws from a desk in Washington. He built a system of measurement.
He showed his work.
Exactly. He went to Woods Hole, he built the lab, he collected the specimens, and he proved that he could provide them with objective reality. He showed them the data. It was the absolute birth of environmental stewardship driven by empirical data, rather than just blind commercial extraction until a resource was completely exhausted. He proved that the government's science was there to save their livelihoods, not respect them out of spite.
That is a delicate tightrope to walk. So, by the late 19th century, America has these three incredible separate scientific agencies running at full speed. One measuring the fixed coast and geodesy, one measuring the moving sky and weather, and one measuring the living sea and fisheries. But they were completely siloed off from one another. They weren't talking to each other. They were housed in different departments. How did this fragmented, disorganized system finally come together to form the unified infrastructure we rely on today?
For that massive shift, we have to skip forward to the era of the 1960s. By this point, these three ancestor agencies had grown into massive, highly complex enterprises. They were incorporating early space-age satellites, advanced Doppler radar, and continent-spanning research networks. But administratively, they were scattered across different federal departments: agriculture, commerce, interior, the military.
But the science itself was starting to rebel against these bureaucratic walls. The data was starting to reveal a fundamental truth. You cannot study the sky accurately without studying the ocean beneath it.
Precisely, or I should say, the data was screaming at them. The 1960s brought the undeniable scientific realization that the ocean, the atmosphere, and the land are not separate independent domains. They are a single, deeply interconnected Earth system.
Like a machine.
Yes, it is a giant thermodynamic engine. The temperature of the upper layer of the ocean drives the formation of storms in the atmosphere. That atmospheric storm dictates the amount of rain that falls on the land. That rain causes agricultural runoff into the coastal ocean, which alters the chemical makeup of the water, which directly affects the spawning cycle of the fish. You cannot model one without modeling all of them.
So, recognizing this, on October 3rd, 1970, President Richard Nixon signs Reorganization Plan Number 4, and this sweeping executive action creates NOAA, the National Oceanic and Atmospheric Administration. It completely fuses the old Coast and Geodetic Survey, the Weather Bureau, and the Bureau of Commercial Fisheries all under one massive administrative roof.
And it is crucial to note that this wasn't happening in political or scientific isolation. There was a massive cultural awakening regarding the environment happening at this exact time. Just 2 months later, in December 1970, the Environmental Protection Agency, the EPA, opened its doors.
Right, the dawn of the modern environmental movement.
Exactly. Yeah. Crucially, the EPA explicitly included an Office of Research and Development, the ORR, specifically tasked with scientifically measuring pollutants. And 10 years prior to all of this, in 1960, the National Center for Atmospheric Research, NCIR, had been established to push the absolute theoretical boundaries of atmospheric science.
The dossier mentions that NOAA quickly earned the nickname the wet NASA. I love that phrasing. It perfectly captures the scale of their ambition and the era they were operating in. NASA was looking out at the stars, trying to conquer the vacuum of space, but NOAA was doing something arguably just as complex, trying to understand the entirety of the interconnected Earth system we actually live on.
And a crucial part of executing that wet NASA ambition was the creation of NOAA's research backbone, the Office of Oceanic and Atmospheric Research, or OAR. It's important to differentiate them. OAR's job isn't to give you tomorrow's weather forecast. That's the National Weather Service.
So what does OAR do?
OAR's job is the long-term foundational understanding of the physics, chemistry, and biology of the planet. They build the incredibly complex supercomputer models that make the National Weather Service's future forecasts 10 times more accurate. They do the foundational science so the operational side can function.
This whole consolidation was heavily influenced by the Stratton Commission report of 1969. Titled Our Nation and the Sea, which basically screamed at the federal government that we desperately needed a unified approach to the environment.
They recognized that fragmentation was holding the science back.
So what does this all mean for you, the listener? To me, before 1970, it is like having 3 highly intelligent but completely blindfolded people touching different parts of an elephant. The Weather Bureau touches the trunk and says, "It's a snake, I'm mapping a snake." The Coastal Survey touches the leg and says, "It's a tree, I'm mapping a forest." The Fisheries Bureau touches the side and says, "It's a wall."
That's a perfect analogy.
Creating NOAA was finally taking the blindfolds off, putting them in the same room, and letting them look at the whole animal together to realize it's a single, breathing creature.
That is exactly it. Managing any single part of the Earth system in total isolation is intellectually inadequate. It is scientifically impossible. You cannot understand an El Niño event by just looking at the sky. A change in trade winds alters ocean surface temperatures in the Pacific, which shifts the global jet stream, which completely disrupts the winter weather patterns over North America, which immediately devastates or boosts a coastal fishing economy in Alaska. It is all one giant, interconnected breathing machine.
And with all these incredible historic institutions finally unified under one roof in the 1970s, we arrive at the absolute central, most provocative thesis of this entire dossier. It is a core reason this massive multi-billion-dollar infrastructure actually exists today.
The thesis is profound, and the entire point of the document. Measurement is a form of governance. It is not a metaphor. It is a literal legal reality.
I really want to dig into this. I am going to push back a little, because when the average person hears the word governance, we think of laws passing in Congress. We think of police officers writing tickets. We think of the IRS collecting taxes. We do not think of a thermometer on a weather balloon or an ocean buoy bobbing in the Pacific. How is a buoy governing me?
Think about how those scientific measurements are actually utilized in the legal framework of society. A nautical chart drawn by NOAA based on acoustic depth soundings, governs exactly where a massive, fully loaded oil tanker can legally and safely sail. If it strays outside the charted channel, the captain loses his license.
Okay, I see that.
A salmon run forecast from the Alaska Fisheries Science Center dictates the strict laws governing exactly how many fish a commercial fleet can legally pull out of the water. If they take more, they are arrested for poaching. An EPA standard measuring PM 2.5 literally governs what a multi-billion-dollar factory is legally allowed to release from its smokestacks.
Let's pause there. PM 2.5. We hear that term thrown around a lot during wildfire season, but what actually is it, and how does the EPA measuring it count as governance?
So PM 2.5 refers to particulate matter that is 2.5 micrometers in diameter or smaller. To visualize that, it is about 30 times smaller than the width of a single human hair.
Wow, so it's invisible.
Completely invisible. Because it is so microscopic, it bypasses the body's natural defenses, the hairs in your nose, the cilia in your throat. It goes deep into the alveoli of your lungs, and it can cross directly into your bloodstream, causing severe cardiovascular and respiratory disease.
And how do they measure something that small?
The EPA measures this using incredibly precise optical sensors that use laser light scattering to count these microscopic particles in the air in real time. When the EPA sets a legal limit on PM 2.5 emissions, they are governing industrial output to protect human biology.
I see. The measurement makes the regulation possible. More importantly, it makes it defensible in a court of law, and it makes it durable over time. If an energy company sues the EPA saying, your emission limits are killing our profits, the EPA doesn't just say, we feel like the air is dirty. They point to the hard, unbroken data set of PM 2.5 measurements and say, here is the exact concentration of poison, and here's the biological threshold.
Exactly. Without the hard data, a regulation is just arbitrary government overreach that will get struck down by the first judge who looks at it.
So the data is the defense.
Raw, verifiable data is the ultimate objective arbiter of reality. If a government cannot definitively prove a physical danger exists using continuous, reliable, scientifically sound data, it has zero legal or moral authority to regulate a private business or protect a citizen. Therefore, simply maintaining the count, keeping the scientific instruments running, funding the satellites, paying the scientists is the most fundamental act of protecting the public. The measurement is the shield.
But this brings up a massive psychological and economic problem, and it's the vulnerability that the dossier highlights. The public scientific records, the data pipelines are almost entirely invisible to the average person. The true value of all this data lives entirely in the negative space. It lives in the catastrophes that didn't happen.
Yes, exactly. The return on investment for NOAA is the shipping fleet that didn't sink on the rocks because the chart was accurate. The value of the fisheries science is the coastal economy that didn't collapse into generational bankruptcy because the quota prevented overfishing. The value of the weather service is the coastal town that evacuated 3 days before the Category 5 hurricane made landfall, resulting in 0 casualties instead of 1,000 bodies in the rubble.
The dossier uses a brilliant analogy here. It's like a smoke detector in your house. You spend money on it, you put batteries in it, it sits on your ceiling doing absolutely nothing but blinking a little red light, and you might think it's an annoying waste of money.
Right, until you need it.
Exactly. You only know a smoke detector is worth the investment the exact second you smell smoke and the alarm goes off, waking you up. But by then, if the smoke detector isn't already installed, it is way too late to drive to the hardware store to buy one. Your house is already on fire.
The profound problem with the smoke detector analogy when applied at the federal level is that we are talking about multi-billion-dollar smoke detectors. We are talking about satellite constellations and fleets of research vessels. And when the primary product an agency produces is disasters that did not occur, it becomes incredibly difficult to justify that massive expense on a federal balance sheet during a tense budget hearing. It looks like bloat because you can't point to a tangible thing you built, only a catastrophe you avoided.
Which brings us to the most vulnerable part of this entire system. What happens when the primary product is a non-event and politicians looking at a spreadsheet decide we can't afford the smoke detector anymore?
Well, now we are going to look at the historical and budget events of 2025 and 2026 as they are explicitly outlined in the dossier. And looking purely at the budget timelines mapped out in the source material without putting any partisan spin on this, what happened was a severe structural change to the agencies we've been discussing.
Absolutely. We are looking strictly at the timeline of events, the math, and the scientific consequences of those budget decisions. So, according to the dossier, in 2025 and 2026, NOAA, the EPA's Office of Research and Development, and NCAR face severe defunding and major structural reorganizations. For example, the dossier states that the EPA eliminated the Office of Research and Development entirely in July 2025. Furthermore, proposed budgets called for zeroing out climate research across the board.
And we can trace the immediate real-world consequence of these specific scientific cuts right back to where we started this deep dive. That small fishing boat sitting in the dark harbor in Alaska. In 2025, due to severe staff cuts, the dossier notes roughly 51 positions were eliminated at the Alaska Fisheries Science Center. The annual biological stock assessment reports simply could not be completed on time.
Because the people just weren't there to do it.
Right. The scientists were not there to go out on the boats, run the acoustic surveys, and crunch the incredibly complex ecological numbers.
So what happens? The North Pacific Fishery Management Council is legally required by federal statute to set harvest limits for the upcoming 2026 commercial season. But they do not have the 2025 data. They're flying completely blind. So as a result, they had to set the 2026 Alaska harvest limits using the previous year's outdated data. They had to use the 2024 map for the 2026 season.
And that is the profound danger of planning a season on last year's map. The ocean is not a static environment. It is wildly dynamic. Water temperatures change, ocean acidification shifts, predator populations migrate, disease sweeps through a school of salmon. When the measurement stops, the darkness returns instantly. You are back to dead reckoning.
It goes right back to our tightrope analogy from the beginning of the show. If relying on the accurate, up-to-date scientific data is like walking a tightrope high above a canyon with a safety net below you, using last year's data because of budget cuts is like walking that exact same tightrope hundreds of feet in the air, wearing a thick blindfold, and just praying that the safety net hasn't been moved by the wind since yesterday. It is terrifying for the people actually out on the wire.
And it goes back to the core concept we discussed with the soldiers in 1870, the long count. You cannot pause a time series, fire the scientists, skip a year of data collection to save money, and then magically catch up later when the budget returns. Once a gap exists in the measurement, the baseline is permanently fractured.
You can't rewind time.
Exactly. The scientific integrity of the long-term mathematical model is degraded forever. You have lost a piece of reality you can never buy back. This raises an important question, honestly, about the fundamental economic definition of fiscal responsibility. If cutting the budget for scientific measurement saves a few $1,000,000 on a government spreadsheet, but leads directly to the collapse of a multi-million-dollar, multi-generational commercial fishing economy because we mismanaged the stock blindly, what did we actually save?
It's a false economy.
It is. The economic cost of the disaster, the bankruptcies, the lost tax revenue, the destroyed communities, dwarfs the cost of the buoys and the acoustic surveys by massive orders of magnitude.
It's penny-wise and pound-foolish on a continental scale. So, as we wrap up this deep dive into the source material, let's look at the incredible journey we've taken today. We started with a solitary fisherman sitting in a freezing, diesel-scented cabin in an Alaska harbor today, checking his smartphone for two numbers. And we traced the invisible infrastructure behind those numbers all the way back to President Thomas Jefferson laying down a bet to map the coast in 1807.
We followed that thread through soldiers tapping out atmospheric pressure reports on telegraphs in 1870, mapping the invisible wind. We followed Spencer Baird wading into the intersecting currents of Woods Hole to count the fish in 1871.
We saw how this massive, invisible machinery was built over centuries, piece by painstaking piece, agency by agency, to replace the terror of dead reckoning with the safety and reliability of empirical, measurable truth.
It is an invisible architecture that literally holds up our entire modern physical economy.
But I want to leave you with a final thought, something to chew on that builds on everything we've discussed today. In our culture, we often think of individual freedom and government regulation as complete and utter opposites. We treat them as natural enemies. But I want you to think about that Alaska fisherman one more time.
Yes, the man on the boat.
His absolute, undeniable freedom to fire up his engine, untie from the dock, sail out into the violent, unpredictable ocean, completely confident that he will survive the weather and catch enough fish to feed his family and run his business. That profound, rugged individual freedom is entirely constructed upon a massive foundation of collective, government-funded measurement. True individual autonomy, ironically, might only be possible when we all agree, as a society, to share the heavy burden of measuring the dark. You can only be a rugged individualist when someone else is telling you where the rocks are.
That is a highly provocative, powerful way to look at it. The safety net isn't a cage restricting your movement. It is the very thing that allows you to walk the wire in the first place.
Thank you so much for joining us on this deep dive into the source material. As you go about your week, keep your eyes open. Keep questioning the invisible systems around you that keep you safe. The weather app on your phone, the clean air you breathe, the safe arrival of the goods you buy. You might just realize you were walking on a massive 200-year-old bridge you didn't even know was there. Until next time.